Advanced Math Trig Honor Students, Mods 2, 3, and 4. It is Friday, April 17th, 2020. So in your notes, again, the date, 4/17/20, top left corner. Today's title, and this will be Monday's title as well, put logarithmic equations. If you remember the last 2 days, on Wednesday and Thursday, we solved exponential equations. So yes, again, you need your calculator today. I have attached another worksheet on Schoology. This is the worksheet Mr. DeMarco had left for logarithmic equations. Now, when you look at the worksheet, again, it'll be titled 417 and 420 worksheet. I'll show you a shot of it real quick here. There are, I believe, 20 questions on this. And if you look at all 20 problems and scan this worksheet over, every single one of the 20 questions has a logarithm in the equation. So yes, we're solving for the variable x, but the equation we're solving has at least one or more logs in them, okay? Now, since there are 20 questions on this worksheet, okay, there's 20 problems total, we're going to do it this way. Today, on Friday, I'm going to do 1 through 9 odd. So I'm going to do 1, 3, 5, and 7. And I'm also going to do problem number 9. So your homework, your assignment, whatever you want to call it, is going to be 2 to 10 even. So bottom line is, today on Friday the 17th, we're going to get the first half of the worksheet, 1 through 10, done. Again, I'll do 1, 3, 5, 7, 9. Your assignment will be 2, 4, 6, 8, and 10. It'd be great, since today's Friday and you're supposed to be watching and viewing this today on Friday the 17th, to just do the 5 problems when you're done viewing the video here and turn those in, and you'll be all done for the weekend with nothing to worry about. However, technically, your 2 to 10 even is not due till Monday at noon on the 20th. So that's how we're going to do this. Monday, of course, the 20th, when I give the notes or video presentation, we'll move forward and I'll do 11, 13, 15, 17, and 19. Your homework will be, 12 through 20 even, and have 5 more logarithmic equations to solve, okay? So it's up to you whether you just want to view the problems first or print them out and have them handy as we do this. It's your call. But I've got them written right here on my notes. Okay, number 1. This is a logarithmic equation because my equation that I'm trying to solve, now I'm still trying to isolate and get x by itself, right? My equation has a logarithm in it. It says ln, so it's a natural log. What are we going to do to solve a logarithmic equation? Well, think about it. We're certainly not going to log both sides like we did the past couple of days. We can't log both sides when there's a log already present in the equation. So what you're going to do is look at the equation and use some of the skills we've developed the last few days. Now, my instinct is telling me this. Oh, I've got an equation that has a logarithm in it. Remember our best friend, Ben? Ben was always our best friend when dealing with a logarithmic problem. So if this is an ln, a natural log, do you agree that the base underneath is understood to be an e? So if I use the Ben idea, remember, every time you see the word log, follow the bouncing finger here. We have a base, an exponent, and a final number. Again, every time I see the word log, I think there's a base, there's an exponent, and then a final number. So guys, technically using Ben here, my base is e. On the other side of the equal sign is always your exponent, in this case an exponent of 5, equals, and then your final number's over on the left side, and there's an x there. So by just using Ben, haven't I in essence already isolated x and gotten the x all by itself? So x equals whatever e to the fifth power is. So go to your calculator. Guys, you do have an E button on there. It's the second function button that's attached to the division sign. Find it. Hit second divided by, because it's E raised to the fifth power. So E to the fifth power gives me, I'm getting 148.413. Oh my gosh. I found my final answer. Okay, so sometimes, yes, it's that easy. Let's go to number 3. Number 3 says ln of 2x equals 2.4. Once again, I've got an equation that has a natural log in it. As soon as I see a logarithm, I'm thinking, let's use Ben, base exponent number. Because it is an ln, a natural log, my base is understood to be an e down here, isn't it? So I've got base, exponent, final number. So I'm going to have e raised to the 2.4 power equals what? 2x. Now, obviously, to get this x all by itself, because again, I'm solving the equation for the letter x, I'm going to divide both sides by 2. The 2's would cancel, and x equals, and you turn to your calculator and let it do all the work again. So again, I'm going to hit E. Guys, I'm going to raise E to the 2.4 power, hit enter, and then that answer that's on your screen, you're going to divide by 2. So doing this on your calculator, come on, work with me, follow with me. I'm getting 5.5115, so to the nearest 3 places, 5.512 looks like my final answer. Okay, not bad. Solving a logarithmic equation. So far, so good. Move to number 5. I look at number 5. It says 2 log 4x equals 0. Now, guys, there's a couple of options here. I would not recommend. Remember when we condensed and expanded logs that if there was a number in front, it must have been an exponent? We don't need to work backwards and expand or condense in this situation, because think about it. That is indeed a dot connected 2, isn't it? Wouldn't it be better just to divide by that 2 and get rid of it first? Because dividing by 2, it cancels. Ends up giving me log 4x equals what? 0. So I've already reduced my equation to that point just by doing that. And once again, guys, just because it's equal to 0 doesn't mean your answer is going to be 0 over here for your x. Doesn't this equation have the word log in it? As soon as I see the word log, I'm thinking, let's use Ben again. But this says log, not ln. On a common logarithm, when you don't see a base down here, remember this base is understood to be a 10. So technically, when I use the word Ben here, I have a base, an exponent, and a final number. My base is understood to be a 10. My exponent is 0 equals, and my final number is 4x. Now careful. Anything raised to the 0 power is what? It's always 1 equals 4x. Oh my gosh. Divide by 4, the 4's cancel, and I did it. X equals just good old 1/4 for this. I didn't even have to touch my calculator. All right, so it's just a case of concentrating and focusing on one step at a time. Number 7 on the worksheet says ln of radical x plus 2 equals 1. Okay, well, guys, take a look at this. There's an equation. It's got a log in it. I'm thinking Ben, since it's an ln, a natural log, my base is understood to be an e, isn't it? So I've got a base of e raised to the first power. Well, I'll put a 1 up there, but that's really not necessary, is it? Equals, and then over here I've got radical x plus 2. Our goal is to get x by itself. Isn't this now a radical equation? To make this root box disappear, I'm going to square both sides. Now, technically, guys, I can ignore that 1, right? Because e to the first is still just e. So technically, to make this square root box disappear, I'm going to square both sides. And I end up with e squared equals what? X plus 2. And to get that x all by itself, I shove over or subtract over the 2. So really, x equals, and right now I've got e squared minus 2, agreed? Well, now I'll turn to my calculator and see what that actually equals, because again, our goal is still to get an answer to the nearest 3 decimal places. So I'm going to hit e raised to the 2nd power. I'm going to hit enter, and then minus 2, enter. Do it on your calculator. I'm getting 5.389. Wow. And again, I solved for my missing x. Okay. Finally, last one. Nice short day today. Number 9. So, ln x plus ln of x minus 2 equals 1. Okay, freeze. And I want to give you a few seconds to think about this. If you were going to try this on your own right now, what would you do first? Now, first of all, let me warn you, we're not going to use Ben yet. Remember, we only use base exponent number when there's 1 log in each of the problems. Okay, the 4 that we just did on the front, there was just 1 log in each one. Oh, there's a plus sign in the middle here. Remember when we did condense and expand? If I ever had the ln of m plus the ln of n, it must have been the ln of what? M times n. Remember the product rule? The log of a product always equaled the sum of the 2 logs. So really, that's why we practiced expanding and condensing. Do you agree if I have the log of something plus the log of something else, that the original problem must have been the ln of x times x minus 2 equals 1? Becomes dot connected. Now, because I've only got 1 logarithm, I can use the Ben idea. Agreed? Isn't my base understood to be an e? So I've got e raised to the 1st power. Again, there's a 1 up there. I don't need to write it. Equals, and then it's this stuff right here. Well, if I distribute, isn't that x squared minus 2x? Oh, now careful, guys. E is simply a number, isn't it? E is 2.718. I've told you that. So if I take this e and move it over to the other side, which I would want to do here, because when I move it over to the other side, I'm solving a quadratic equation. I'm going to get 0 equals x squared minus 2x minus e. Oh, so I'm solving a quadratic equation. It's equal to 0, so it's in standard form. Now, normally, you'd, of course, try to what? Factor that, since it's a trinomial, into 2, but that's not going to work. Obviously, the factors of e are e times 1, and it's not going to equal the middle number. Oh, my gosh. Now, this depends on how powerful your calculator is. But, guys, the only way to solve this quadratic equation, since it doesn't factor, is to use, oh man, the quadratic formula. Agreed? So things can get a little complicated here. Since it didn't factor, I'm going to use good old, what, negative b plus or minus the square root of b squared minus 4ac all over 2a. I have no choice other than to use the quadratic formula. If you've got that programmed into your calculator, great. Obviously, a is 1, b is negative 2, and c is negative e. Agreed? You've got your a, your b, and your c. If you've got your calculator programmed to do that, great. If not, I'm going to do it real quick here. Try to do it quick by hand. Negative b. Well, that'd be the negative of what? Negative 2, which is 2. plus or minus square root b squared. Well, again, my second value is -2. -2 squared gives me 4 minus 4 times what's a? 1 times c, which is -e. Oh boy. All over 2 times a, so that's going to be 2 times 1, which is 2. Cleaning this up, obviously if I have -4 times 1 times -e, it's going to be 2 plus or minus the square root of 4. What, a negative times a negative is a plus 4e all over 2. So calculator-wise, I'm going to take 4, I'm going to times it by e, and then whatever that answer is, I'm going to add 4. So right now on my calculator, I'm just doing what's inside the root box. So 4 times e gives me 10.873, but then I got to add 4 to that, giving me 14.873, blah, blah, blah. I'm leaving that on my screen. Right now, I've got 2 plus or minus the square root of 14.873 all over 2. So I'm going to square root that number that's on my screen. So I'm square rooting that answer that's on my screen, and I'm getting 3.857. So this is 2 plus or minus 3.857 all over 2. Keep following with me. So guys, 2 plus 3.857 would be what? 5.857 divided by 2. So I'm pushing 5.857 divided by 2, and I'm getting 2.929. There's one answer. Now watch this. When I take 2 minus 3.857, do you agree that that's going to be a negative 1 point something divided by 2, creating a negative answer? Well, guys, a negative answer makes no sense, because if you look at the original problem, if I circled a negative answer here, can a logarithm ever have a negative number next to it? Think about it. The answer is no, isn't it? Because you can't take a base of e, raise it to some exponent, and have it turn into magically some negative number. So guys, an ln or an log can never end up with a negative number next to it as the missing number. So the negative answer, no matter what it would have been, the negative answer that we would have created would not have made sense and would have got crossed out anyway. So amazingly, wow, that's a good problem. 2.929 is our final answer. So if you got to work a little bit on number 10 on your homework, certainly things can get a little more complicated than we foresaw. Okay? All right. You've got the worksheet attached onto Schoology. You either look at it and write down the problems or print it out. It's your call. But your homework is on that worksheet, 2 to 10 even. Just those 5 problems. It'd be great if you could turn them in sometime today on Friday the 17th. Then you've got the weekend off mathematically. Otherwise, maybe Sunday night or Monday morning at the latest. These would be due by Monday the 20th at noon, okay? Great job, guys. You had a good week. Appreciate your time and effort, and we'll see you on Monday.